Okay, guys, the purpose of this video, and it's going to be a really short one, during Monday's lecture, I was trying to demonstrate something at the board, and I did something on the board that wasn't mathematically sound. It wasn't as bad as it looked, and I'll point out to you why it wasn't as bad as it looked, but you know, I'm going to blame it on too much tequila in Mexico last week, or whatever. But anyway, there's a couple of things I really appreciated. Appreciated the fact that I did something at the board that was mathematically, well, it just wasn't sound mathematically, and you guys let me know about it, and that is good. And I have to admit, a couple of reactions kind of I thought were weird, some of the eye rolling and stuff, but you know, people got to do what they got to do. But aside from that, let's not you know, lose sight of what's the most important here. I put something on the board that wasn't mathematically sound. You guys let me know about it, which you should. It actually reminds me of a story that my doctoral advisor told far too many times. If you ever sit down and talk to him longer than a second, he was one of these people that wanted to let you know he had a PhD from the University of Chicago, which is a fairly prestigious mathematics and statistics, or has pretty prestigious mathematics and statistics programs. And of course, he got his PhD, same thing I have mine, in statistics, measurement, and evaluation. In fact, he and another guy from Chicago came to University of Kentucky and started that program and that degree. But anyway, something he told that I'll always remember, he started his PhD at the University of Chicago, and he was nervous. He was nervous about whether or not he was able to compete with some of the best and the brightest, and he was concerned about whether or not he would complete his degree. Maybe it's something you guys are starting to maybe feel a little bit of yourself. I know I certainly did when I was in grad school. But he tells a story about when he went to orientation, his first orientation, again at the University of Chicago, just starting his PhD. He told the story about how the orientation advisor, who was his graduate advisor, asked what was their biggest fear. And everybody was obviously the biggest fear is not successfully completing the program. And he said, "I tell you what." And evidently he had done this many years, and he was prepared. And he pulled out a kind of a fake degree and said, "Here's your degree. Stop worrying about it. You're going to get your PhD. You're going to complete this successfully unless you decide to drop out of the program." Now, I think that's a little bit of a stretch, but I get where he's coming from. Graduate programs are built to get people through and get people to succeed, as much as you think it may not be with all the videos and stuff that we're requiring you to watch. But anyway, he followed it up by saying, "Here's your degree. It's over with. Done. You're going to get your degree. Stop worrying about it. Let's just go through the process together." But the next thing he said I thought was interesting. He said, "Here's your degree, but what I want you to do over the next 5 years or 4 years or 6 years, however long it takes for you to complete your PhD, is I want you to challenge everything that your professors say. Everything they say, challenge them." And I think, having gone through this and completed a couple of masters and a PhD, I can really see the value in that. So when Darbro, Whitaker, Desario, whoever it may be, well, for some reason my deal kicked off here. We do something, challenge us. Just try challenging. Maybe. Hold on, I gotta get this back. Okay, maybe without some of the eye rolling. Okay, gang, enough of that. All right, what happened here? I want to demonstrate. When we came in, and I just refer to this as Q, just because it is going to make some of the notation a little easier when we start looking at the partials. But we all, when we were looking at the partial of Q with respect to beta, we were all in agreement that nothing's going to happen much here. But there was some debate, and there should have been, about this term right here. This term right here, I told you to think beta squared, and I want to show you that I wasn't really far off on that. Mathematically, not sound. But I didn't say this is a theorem. I didn't say this is a lemma. I didn't say it's a postulate. I said think, which is clearly a very, very lackadaisical mathematical idea, and that's the way I intended it to be. Unfortunately, I couldn't follow up with the rest of it on the fly, The first thing I did that night when I got home is cracked open a beer, sat down, and saw that this was something that could be worked in 5 minutes. So what I want to do now is I want to examine this term right here. The reason is, of the two, this is the hardest. This one's by far the easiest. So I thought I don't want to go through both of them just because I know you guys are getting sick of listening to me on videos. So I thought if I'm going to do this, I'm going to examine the most difficult term. And it's really not that difficult. So the first thing I want you to remember, and we're going to need this in a couple of places, is that X transpose X is just this. And if you know anything at all about multiplying matrices, and we actually developed this back in one of the earlier matrices, in one of the earlier videos anyway, we can see that when we take the linear combination of the first row and the first column, we get 1 plus 1 plus 1 plus 1. There should be no surprise that's in. When we take the linear combination of the first row and the second column, we get x1 times 1, x2 times 1, and so on and so forth, which, and I'm not going to do the subscripts, but some of the x's. When we focus on the next term, the first term in the second row, we see that we get x1 times 1 plus x2 times 1, no surprise. And the next term we get x1 times x1 plus x2 times x2. Again, no surprise. So guys, X transpose X, when we multiply it out, looks like this. Now the next thing I want to look at is I want to look at beta transpose X beta. Well, we know the beta transpose is going to be beta 0, beta 1. And guys, technically, this is the hat because we're doing a prediction, but that's just going to get extremely messy, and I think that I think we're all on board without that. Okay, so then we have X transpose X, which we just saw. And guys, we clearly should know by now that beta is this. Now, what are we expecting here? When we look at the size of the matrices, we have a 1 by 2, a 2 by 2, and a 2 by 1. So I'm going to multiply these two first. So what I'm looking at here is a 1 by 2 matrix. So I have one row and two columns. Okay? So ultimately, I'm going to have a matrix that looks like this. And again, this is my beta transpose X transpose X, and then I'll eventually come in and multiply that by beta. Now, multiplying everything out here, when I take beta 0, beta 1 as a linear combination of n times n and the sum of x, I think it's really clear that this first term is going to be, let me make sure I'm doing this correct, beta 0 n plus beta 1 sigma x, okay. And this is just annoying to me here. Okay, and then take the linear combination of the next. We're going to get, so beta 0 some x's, beta 1 some x's squared. So just as we anticipated, we get a 1 by 2 matrix. Now let me get rid of this down here. Now what I want to do is I want to come in and multiply this, and I wish I had room to put this right here, but I don't, times the beta matrix. Okay? So ultimately, guys, what I'm going to get, I think it's clear here that I have a 1 by 2 matrix, and I have a 2 by 1 matrix. So I'm going to end up with just a 1 by 1 matrix. All right. So guys, what I get here is I get, looking at the linear combination, I'm going to take the the first row times the first column. So I'm going to take my beta 0 times this term and my beta 1 times this term. So ultimately, boys and girls, what I'll end up with, I wish I could write larger. Let me go back here. So we got beta 0. All right, so beta 0. I think it's going to be easier for me to do this. Beta 1, okay. And this should be beta 0 sum x. And it should be beta 1 sum x squared, yeah. All right, gang. Let's just distribute stuff. All right, that stuff should be clear, guys. These are not matrices. These are coefficients of the model, so they are commutative. And we end up getting this term. Now, I told you in class that when we took the partial of q with respect to beta, we were really taking the partial of q with respect to beta 0 and the partial of q with respect to beta 1. And then I get into that wacky notation, thought box beta b squared, all that, which really isn't as bad as it looked, but it was bad enough. So guys, what I want to do now is I want to go back and write this as take the derivatives. So I wish I could copy that. No, well, I just have to go back and forth. So let's take the partial with respect to q, because I'm only looking at one term here. So ultimately, what I'm going to do here in both cases, and I'll tell you what, this just doesn't give me enough room. I just can't handle that. All right, let's go the partial with respect to beta transpose x beta with respect to beta 0, and then let's look at the partial of just, again, the term x transpose x beta with respect to beta 1. All right, gang, when we do this, and again, let's think about this as a 2x1 matrix. Let's be consistent here. All right, gang, so when we do this, when we take this with respect to beta 0, okay, it should be pretty clear that we get 2 beta 0 in plus 2 beta 1 sum x. And then we'll get another term too. And with respect to beta 0, it's just 0. Okay. Now, the other term down here with respect to beta 1, we're going to get just 0. And the other term, we're going to get 2 beta 0 sum x. Might be the ugliest beta ever in the history of betas. And the last term, we get 2 beta 1 sum x squared. All right, gang. What I want to do now is I want to take this and rewrite it as a matrix multiplied by beta 0, beta 1. Now, when I do that, I'm going to get, so this is going to give me 2n plus 2 sigma x. And the bottom row is going to give me 2 sigma x. Ah, Doug, come on. 2 sigma x, 2 sigma x squared. Let me make sure it's right there. Yeah, all right, good. Now, it should be no surprise to anyone that we can rewrite this as this. And kind of going back to where we started at, we know that this right here, this 2 by 2 matrix is nothing more than x transpose x, and of course this is beta. So guys, the last term that mysteriously appeared by my little thought box of thinking of it as b squared, well, the derivative of b squared is 2b. But again, although that might be a way to think about it, it is certainly far from mathematically sound. So guys, I think, Aaron, you're the one that said, I'd like to see a proof of that. Well, buddy, this one's for you. And for other people, too. So, of course, you may have already got it figured out by now because there's really not a lot going on. So, guys, the other term, you know, I'm going to let you guys work on that one. Let's go back to this term right here. Now, this is by far the easiest one to work. So really, you're not taking with respect to beta transpose. You're taking with respect to beta, which is the column vector, a 2 by 1 vector, beta 0, beta 1. So, guys, I hope this clears up a little bit. One more thing I've got to tell you. I'm just full of myself in terms of errors. There was an error on the exam, and I had a complete bozo moment. And I know exactly after I started thinking about it. Ralph, this one's for you, buddy. You must have thought I was insane the other day. There was a question that when I edited my exam, the question that I wanted you guys to get, you didn't get. And it was one of the true-false. And it had to do with some of the squares of the residuals being 0. Well, it's clearly false. We minimized the sum of the squares of the error. And for some reason, I couldn't even read that problem without thinking of the problem that I thought I'd put there. And who knows? If you can figure me out, I'm sure my wife would like to sit down and talk to you. And maybe some others too. So, guys, long story short, I had the key wrong. I made the key on a different question. So instead of you guys bringing it back in and me subtracting 2 points from whoever actually had it wrong, but I counted it right, or right and counted it wrong, I'm just going to give everybody 2 points, and it's not going to matter anyway. So guys, that's the end of the lecture. By now, you probably know that you have 6 videos and an assignment that'll be due before your final exam. Just a little bit of information. Your final exam schedule. And there will be follow-up emails, so you could cut me off here if you want. From 3 p.m. to 5 p.m. I'm sure Dr. Whitaker will give you longer than 5 p.m. if you need it. He's extremely accommodating like that. So 3 p.m. to 5 p.m. in Massey 109 you'll take your analysis final. On Friday, you'll take from 9 a.m. to 11 a.m. You'll take your number theory. And from 1 p.m. To 3 p.m. You'll take your regression. I haven't really figured out the exam yet. I kind of wanted to wait. I don't want to make out the exam right now for reasons I'm not going to talk about, but I want to wait and give it a couple of days about the regression. I'm not really sure whether it's all going to all be theory. I'm not sure how I'm going to integrate R into it. So I don't know if I don't know how this is going to work. And I don't know if half of it will be taken in the computer lab and half of it in the lecture. I just don't know yet. There's still some things I want to think about. So, guys, that's what's up. Don't give up on me now, man. It's you should be able to see the light at the end of the tunnel by now. And I think in terms of my assignment, I think you're going to find that assignment number 5 is probably one of the more straightforward assignments. So, guys, have a good one, and I will see you guys, I guess, again on August the 1st. All right, take care.